Hello there, this is Ms. Page. In this lesson, which is the second lesson in our Unit 2 on rational expressions, we are going to focus on how to add and subtract rational expressions. In the first lesson, we talked about how to reduce rational expressions. And when we reduce rational expressions, we do so basically the same way we reduce numeric fractions, by determining common factors and dividing out those common factors, reducing them to 1. So when we add and subtract rational expressions, we actually follow the same procedure as if we're going to add or subtract numeric fractions. So prior knowledge is looking at adding two fractions. One of the things that we need to add fractions is a common denominator. So the lowest common denominator is determined the same way for numbers as it is for rational expressions. We look at the breakdown of the factors of the denominators, any factors that they have in common, such as 2, we use that once, and any factors that are not common to both denominators, we use each of those once. And so that gives us a lowest common denominator of 40, which is also the least common multiple of 10 and 8. Then we have to multiply each fraction by a ratio of 1 so that our denominators become that lowest common denominator. And once those denominators are the same, then we can add the numerator values together. And if necessary, we would reduce the final fraction, which again has the denominator of the LCD. And then if it reduces, it would change. All right, so we're also going to look at excluded values. So excluded values for rational expressions. When we're adding and subtracting 2 or more, we use all of the excluded values from each of the individual expressions that are being added or subtracted. And so we're looking at all the denominators for each of the expressions. So this is basically the procedure that I was explaining, same as if we add or subtract numeric fractions. We need to find our lowest common denominator. We need to multiply by ratios of 1 that include factors to create that LCD. And then we add or subtract the numerators, making sure we apply this to polynomials and give, of course, the denominator remains the same, the LCD. And in these problems with rational expressions, once in a while they might reduce after we add or subtract the numerators, but not very often. All right, so here we have a subtraction problem. And so we're subtracting two rational expressions. So we can actually take care of the first step in subtraction, finding the lowest common denominator, and figuring out our excluded values kind of at the same time, because we need the denominators to be completely factored. So for this trinomial, our denominator would factor into x plus 4 times x plus 5. And the second denominator has a GCF of 3, which would be then times x plus 4. So we would look at each of those unique factors that involve our variable for the excluded values. So I'm going to do that first, excluded values. So I need to know, because x plus 4 can't be 0. So that means an excluded value would be negative 4. X plus 5 cannot be equal to 0 because it's a denominator factor and division by 0 is undefined. So x cannot be negative 5. 3 is a number, so I ignore that one because it can't be equal to 0 anyways, no matter what we're looking at. And x plus 4 here in the second denominator is, we've already done that one. So our excluded values to answer that part of the problem would be that x cannot be equal to negative 5 or negative 4. Again, best to get in the habit of doing that least to greatest, because sometimes that matters, and if you already have that habit of going least to greatest, you don't have to worry about retraining yourself. All right, so now I'm going to go on with actually doing the subtraction in this problem. So I need my lowest common denominator. So I notice that my two denominators have a common or shared factor of x plus 4, so I'm going to use that once. The other factors they do not share, so I use each of those once. I use 3 once, I use x plus 5 once. So this is my LCD, those 3 factors. I'm not going to multiply them together because what I want to do is going to be easier to do without multiplying at this particular point in time. So now I'm going to alter the structure of my problem so that my denominators become the common denominators. So I have my 2x, and I'm going to use the factored form of its denominator. So, and comparing the factors in this denominator to the LCD, it's missing the 3. So my ratio of 1 then, I multiply by 3 over 3. So now my denominator will match the LCD. Then I have my subtraction sign. And the second denominator has the factors of 3 and x plus 4, so it's missing the x plus 5. So I use my ratio of 1, or create it using the x plus 5 factor. So now this second denominator matches the LCD. So now what I have to do is I have to multiply my numerators together at this point. You don't have to multiply your denominators at this point if you don't want to, okay? So 2x times 3 would be 6x over the LCD. So this is basically our third step. And distributing our 5, because it's a monomial times a binomial structure, it gives us 5x plus 25 over the LCD. Now here's where I see a lot of people make mistakes, so make sure you're staying with me, make sure you're paying attention, because here's where we're technically taking 6x and subtracting all of that second numerator, the binomial 5x plus 25. So again, to subtract all of it, we must subtract each of its terms. So that is going to give us then minus 5x and minus 25. Do that first before you combine terms. If you combine terms first, then you are not going to be subtracting that 25. You will be adding it instead. So we have 6x minus 5x, which would be x, and our minus 25, which doesn't combine with anything, over our LCD as that next step. So now, sometimes it can be acceptable to leave in an addition problem or a subtraction problem your denominator in its factored form. I will accept it that way for addition and subtraction problems only. It's always acceptable to multiply it out. So for example, this would be x squared plus 9x plus 20, and then distribute the 3. So if you're ever in doubt as to whether it's okay to stop with the factored form, then just don't stop. Multiply it out, because that answer will always be acceptable. So we get 3x squared plus 27x plus 60. So there's my best answer for the subtraction. All right, let's take a look at another one. All right, here we have another subtraction problem, reinforcing the process, but also this problem has been specifically chosen because the factoring in the denominator is often one that we see students stumble over. Like they just don't remember exactly what they need to do here. They're not recognizing the structure. All right, so I'm going to factor my denominators. 4x squared minus 9, I have to recognize is a difference of two squares. It's 2x quantity squared minus 3 quantity squared. So it's going to factor, that's not the factoring, remember, that I just did. The factors are two binomials, 2x plus 3, 2x minus 3. Then the 2x squared minus 3x, I have to realize that's a GCF factoring. Both terms have a common factor of x. And then that would be times 2x minus 3. So again, it might be a good idea to do excluded values at this point. So I'm going to go left to right with my denominator factors. So what I know for my excluded values is 2x plus 3 can't be equal to 0. So here this is again two-step algebra. We would subtract the 3. You always undo addition or subtraction first, remember. Then divide. So x cannot be negative 3/2 or negative 1.5. 2x minus 3 cannot be equal to 0. So again, we undo that subtraction first and then divide. So x cannot be positive 3/2 or 1.5. Don't lose your monomials. X cannot be 0. And 2x minus 3 over here is a repeat, so we don't have to do that one again. So our excluded values, we have to realize this time we have 3 of them. And Least to greatest would be -3/2, then 0, then +3/2. All right, so now I'm going to move on to the subtraction. So I need that lowest common denominator. So looking at the factors in my denominators, I'm looking for shared factors. So 2x minus 3 is shared, so I'm going to use one of those. The other factors are not shared, so I use one each of those. So I use 1x, and I use 2x plus 3. So my LCD is those three factors. So now I am going to multiply each of my ratios by whatever ratio of 1 I need to create the LCD in both of them. So I have the x plus 4, and again I'm going to use the factored form of this denominator. So comparing the factors in this denominator to the LCD, it's missing the x. So that's what I use to create my ratio of 1. Sorry, trying to get my color to change here. There it goes. The second one, I have x minus 2 over x times 2x minus 3. So it has these two factors of x and 2x minus 3. It does not have the 2x plus 3. So that's what this ratio of 1 will be created with. With binomials, it's not a bad idea to put parentheses around them to remind yourself that you are going to have to distribute in this multiplication step, which is coming up next. So here, I'm going to distribute the x to the x plus 4. That gives me x squared plus 4x. I'm going to wait to do my denominator later. But if you want to do it now, you could do it now. And here, I have to distribute twice, so I'm going to get 2x squared. I'm going to get a 3x and a negative 4x, so minus x minus 6 over my LCD. Doesn't really matter if you write the binomial factors in the same order here or as the first one or not, just so long as they individually match each other. So now is our subtractions. Remember what I said in the previous problem about being super careful, because you are subtracting polynomials here. You're taking this polynomial minus this one, which means that we have to subtract each of these three terms before we combine. So I'm still going to have my x squared plus 4x. I'm going to be subtracting the 2x squared, be subtracting a negative x, I'm going to be subtracting a negative 6. So each of those minus negatives will become a positive. Plus a positive. Not plus a negative, plus a positive. So now combining my like terms, I'm going to clean this up a little bit. It's bugging me. So plus. I like that better. So I have x squared and negative 2x squared, so that's negative x squared. I have 4x plus x, so that's plus 5x. And then I have plus 6. And that is all over my LCD. Don't lose your LCD. That's another common mistake I see. Like so. Now, again, like I said, with addition and subtraction problems, I'm okay with the factored denominator as in the final answer. But again, if you forget, like you're doing a test question, you can't do that with multiplication division, which we haven't talked about yet, or with reducing, which we have talked about. So if you're like get confused, can I leave it factored here or not, then just multiply it out. So these two go back to remember 4x squared minus 9, and then distribute the x. So the best answer is with a denominator of 4x cubed minus 9x, like so. All right, we're going to try a practice problem. So pause your video here, give this problem a try. Okay, so let's take a look at what we should get. All right, so over here is where it goes through the excluded values. So x cannot be 3 or 4 in this case. Here, our denominator is shown in factored form. Your numerator should match exactly. This has included the excluded values over here. It's fine to have them in just one place. And if you wrote out your denominator and in multiplied form, I guess, let's see, that's x squared minus 7x plus 12 times 8 would be 8x squared minus 56x plus 96. So that would be what I would say is the best answer. All right, moving on. So back to an example. So here we're looking at a problem. It's addition, but that doesn't matter really, except for, we're distributing addition, not subtraction, so we don't have as many issues with sign mistakes and stuff. But here the big issue or the difference is our types of denominators. We have a monomial denominator of x squared and a binomial denominator. So I need to factor my binomial denominator, which has a GCF of x. And remember, x squared means x times x, okay? So when I'm doing my excluded values, then x cannot be 0. X minus 5 cannot be 0, which gives me x can't be 5. But then x squared is a repeat of factors of x, so I don't have to do that again. So my excluded values are that x cannot be 0 or 5 in this case. Those would create, remember, denominators of 0, which means division by 0, which is an undefined situation in mathematics. We don't allow that when we're working with these types of expressions. So now I'm looking at doing my addition. So again, same procedure. I need my lowest common denominator. So this is another place where it's important to remember x squared means x times x, because x is a shared factor, so I'm going to use one of those. And then the other x and the x minus 5 are not shared, so I use one each of those. So I use this x because it's not shared, and I use the x minus 5. So my lowest common denominator is actually x squared times x minus 5, not x cubed, as I see some people think. All right, x squared is the lowest factor between the x's. It's like the lowest common multiple. And so you can write it as x times x or x squared, whichever you prefer, not a big deal. So now I'm going to do that procedure where, again, I'm going to use the factored form and do my multiply by my ratios of 1. So here I have to realize, okay, I have a factor of x and a factor of x minus 5, so I need this other factor of x, and that's what I use for this ratio of 1, plus my x squared. So I have the x squared. What I need here is that factor of x minus 5. And now is when I have to realize I have to multiply the numerators. So here I have to distribute the x to 2x minus 4. That gives me 2x squared minus 4x over my LCD. Here I have to distribute twice because I have a binomial times a binomial. I get x squared plus x minus 30 over the LCD. Now, technically the concept is the same. I am adding each of these, but when we add, the signs don't change. But we are still technically adding each of those. So we have 2x squared plus x squared, which gives us 3x squared. Negative 4x plus x, which gives us negative 3x. And plus negative 30, which gives us a minus 30 over our LCD. And again, this would be okay as a final answer. Best answer is to multiply the denominator out into standard form, which would be x cubed minus 5x squared, like so. Notice some of you might be tempted because you might see that common factor of 3 in that numerator to factor that out. Again, simplest form should have, at the final end, should have no parentheses in it. I am making an exception for denominators, not for numerators. No exceptions for numerators. And again, if you can't remember when I allow those exceptions, just always multiply stuff out to put it in standard form. All right, let's take a look at this one. So here we have another addition problem. Again, basically same overall procedure as far as the beginning of the problem for a subtraction of this type. Here the key thing is, and what's different about this one, is that our denominators are both binomials, but they're prime binomials. And so the two denominators, their common factor is 1. So excluded values, we have a factor of x minus 4 that can't be 0, so x can't be 4. And we have a factor of x plus 3 in our denominator that can't be 0, so x cannot be negative 3. So conclusion, all the excluded values, x cannot be negative 3 or positive 4 from least to greatest. So now for doing the addition, I want my lowest common denominator. So I have to realize that x minus 4 is the only factor I've got here. X plus 3 is the only factor I've got there. Again, those are prime binomials. 1 times themselves, that's all they've got. So there's no shared factors really except 1, which doesn't matter. And so the non-shared factors are the x minus 4 and the x plus 3. So this is then our lowest common denominator, the product of the two denominators. So now I'm going to take my first ratio, and it needs a ratio of 1 multiplied by it that involves the x plus 3, which we need. Then I have my second ratio, and I'm going to multiply it by the ratio of 1 created using the factor of x minus 4, which is what this denominator needs. So now I'm going to do the multiplication in the numerators. So here I have to distribute negative 4. That's over the LCD, which you could multiply out right now if you want to. Here I have to distribute the 3x over the LCD. Now I'm going to add my numerators. So technically I'm adding both of those. Here again you want standard form, which starts with the highest power of our variable x. So we have 3x squared, because we're adding 3x squared and there's no other like terms. We have a negative 4x plus negative 12x, so that's a negative or minus 16x. And then we have the constant of minus 12 at the end, over. If you want to leave it this way, okay. But again, best would be to multiply it out. Whoops, I need an x. So I'd get x squared minus x minus 12. Best answer. All right, let's see what we got next. Okay, looks like we've got another one. Also addition in this case. So, a little more complex denominators. They're both trinomials. So we want to make sure we understand. There is something that happens here because one of these trinomials is what we call a perfect square trinomial, as we're going to see. So we are going to start by factoring our two denominators completely. So the first denominator factors into x minus 3 times x minus 8. The second factors into x minus 3 times another x minus 3. So this trinomial x squared minus 6x plus 9 is a perfect square trinomial because it factors into x minus 3 quantity squared. So our excluded values, going left to right with these denominator factors, x minus 3 can't be 0, so x can't be 3. X minus 8 can't be 0, so x can't be 8. And then x minus 3 over here is a repeat, so we don't have to do that. So for the excluded values, we have x cannot be 3 or 8 as a conclusion. All right, so now for the addition, my lowest common denominator. Here's where this one's a little different and why it's one of our examples. So this x minus 3, it's always a 1-to-1 when you're looking at shared or common factors. And we actually saw this with the one with the denominator of x squared and a binomial, where x was squared, one x was shared and the other x was considered not shared, or it's kind of left over. So one of these x minus 3's is shared, so we use one of those. The other x minus 3 is not shared, neither is the x minus 8, so we have to use one of these other x minus 3 that was left over and one of the x minus 8s, and one x minus 8. So we have two x minus 3's and one x minus 8 as our LCD. So now I'm going to use the factored form of the denominators again, makes it easier for comparison. So I have those two factors. I need another x minus 3. Might want to put parentheses around that x plus 2. Helps you remember you distribute in the next step. So here I have 2x minus 3's. I need the x minus 8 to match that LCD. So now, remember, we're going to have to multiply numerators together. So we're going to distribute the negative 14. That's going to give us negative 14x plus 42 over the LCD. And you can write your LCD this way if you want to, with your x minus 3 quantity squared. Here we have to distribute twice. We get x squared minus 6x minus 16. Now we are to the point where we're going to add so we're adding each of these three terms to the terms before. Again, standard form would start with the highest power of x squared, so we have a positive or plus x squared. Negative 14x and plus negative 6x gives us a negative 20x. Positive 42 plus negative 16. Let's see if I can do that math. So 42 minus 10 would be 32. 32 minus 6 would be 26. So plus 26 over my LCD. And this is an okay answer. Again, best answer would be removing the parentheses from the denominator. The x minus 3 quantity squared would be x squared minus 6x plus 9. Remember, that's what we factored at the beginning. And then distributing the x minus 8, we get x cubed minus 6x squared plus 9x minus 8x squared plus 48x minus 72. So that's going to give us here x squared minus 20x plus 26 over x cubed minus 14x squared plus 57x minus 72 as our best answer. All right, I believe there's a practice problem next. Yep. All right, I'd like you to pause your video and try this problem, please. Let's take a look now what you should have gotten. All right, so here is where it works out the excluded values, but it doesn't really put it into that final form of x not equal to. It does do that over here, is where it. And so here is your LCD when you're doing your addition. Here's your ratios of 1, showing the multiplication, the addition, the simplification. Again, best form of this answer would actually have the denominator multiplied out as x squared plus x. All right, that finishes up this lesson. I hope you have a wonderful day.